A successive approximation ADC is a type of analog-to-digital converter that converts a continuous analog waveform into a discrete digital representation via a binary search through all possible quantization levels before finally converging upon a digital output for each conversion. Block diagram. Key: DAC equals digital to analog converter, EOC equals end of conversion, SAR equals successive approximation register, second per hour equals sample and hold circuit, VAN equals input voltage, VOF equals reference voltage. Algorithm: the successive approximation analog to digital converter circuit typically consists of 4 chief subcircuits. A sample and hold circuit to acquire the input voltage. An analog voltage comparator that compares VAN to the output of the internal DAC and outputs the result of the comparison to the successive approximation register. A successive approximation register subcircuit designed to supply an approximate digital code of VAN to the internal DAC. An internal reference DAC that, for comparison with VREF, supplies the comparator with an analog voltage equal to the digital code output of the SAR-in. The successive approximation register is initialized so that the most significant bit is equal to a digital 1. This code is fed into the DAC, which then supplies the analog equivalent of this digital code into the comparator circuit for comparison with the sampled input voltage. If this analog voltage exceeds VAN, the comparator causes the SAR to reset this bit. Otherwise, the bit is left to 1. Then the next bit is set to 1 and the same test is done, continuing this binary search until every bit in the SAR has been tested. The resulting code is the digital approximation of the sampled input voltage and is finally output by the SAR at the end of the conversion. Mathematically, let VAN equals XVOF, so X in, minus 1, 1, is the normalized input voltage. The objective is to approximately digitize X to an accuracy of 1/2 n. The algorithm proceeds as follows. Initial approximation XO equals 0. If approximation xi equals xi1, s, xi1, x, /2i. Where, s, x, is the signum function, sgn, x plus 1 for xa permel 0 yen, minus 1 for x,